Mr. Frog, what's up? Heyo. Oh, that's cool. Yeah, you're gonna do integration after your break. Yeah, that's integration is something that's very important and kind of fun to do because you know it really tests every single skill that you should know. If I'm lagging or anything, I see that I'm kind of lagging on my end. Just let me know, and that's something that I'm gonna have to fix later on. It's definitely my internet. I am trying a whole different new setup today, so hopefully it's not taking it too much bandwidth. But as long as you guys can hear me, everything should be good. Again, let me know if you guys can see this whiteboard on the screen or blackboard. Doesn't look like much is coming out on mine. I'm just making sure that it's working. Just give me 1 second. Okay, it looks okay. The stream is lagging, but the audio is good. As long as the audio is good, that's fine. Again, I'm gonna try to fix that. It's got to be my computer. I think I have way too many things open. So I definitely I gotta change that up. But anyway, as we're doing this, and I'm just trying to figure this out, I hope everyone's summer is going well. Hope everyone's looking forward to the school year. And as it looks like we have the proper integral there that I wanted to do on the screen. So if you're looking at this, go ahead and let me know if you guys have any suggestions on what we should do. I have the integral of sine x times secant x, and to some people this could be really easy. Some can find it difficult. Everyone's a little rusty, I'm sure. I'm gonna be. So if I make any mistakes, any typos, please let me know because I could already anticipate them. Okay, so as you're seeing that in the chat, let me know of any methods that we should do here. Every time I see a secant x, I'm just going to go ahead and start rewriting that because I'm hoping that's probably going to help us. So if I rewrite that secant x turns into 1 over cosine x. And that's just going to turn into sine x over cosine x dx. And now we have a beautiful fraction of sine x over cosine x. Lava Mob 64, yes, you are absolutely correct. That's exactly what we did. We rewrote the secant as to 1 over cosine, and then we're going to use u sub. So in this case, I like to show all the work, make my u equal to my cosine of x, and my du is equal to negative sine of x dx. And there's many different ways that people solve this. Okay, before I continue, I'm so sorry guys. Again, we're back after a long hiatus or a long break. So if the stream is lagging, someone said audio was good, but the stream was lagging. I apologize, but nothing is showing up on my screen yet. So I'm actually just gonna, I'm not gonna be able to read the chat for a second, but I'm just gonna go ahead and erase this, and maybe I can read the chat elsewhere. But everything hopefully is looking good. Oh my goodness, I wish I can stream or I can read the chat from another window. But something is definitely taking up a lot of my bandwidth computer, so I truly apologize. But anyway, if you guys are seeing this as I try to figure this out, I'm just gonna go ahead and start rewriting my integral now that we found the value of u and we have our dx, which before we continue, I'm just gonna rewrite this and isolate the dx. So I'm gonna write this as du over negative sine of x is equal to dx. And that's gonna help us rewrite our integral. And now what we're gonna have is integral of sine x over our cosine x, but remember that is our u. And now we have times, and the dx is gonna be du over negative sine x. And that's exactly what we want because now the sines of x are gonna cancel out. And we're going to have a simple integral of negative integral of 1 over u du. And from there, hopefully you guys can see that we can go ahead and integrate this. This is just 1 over u. So this is negative natural log of absolute value of u. And we have our plus c. But because this integral was in terms of x, we have to rewrite this because we have it in terms of u, so we're just going to use the u that we found, which was the cosine, and now we have negative natural log of cosine of x plus c. It was a pretty simple one in my opinion. Nothing that difficult. It was just a matter of rewriting, but again, some people could be rusty, including myself. So let's go ahead and erase this, and now we can do a different integral. And if you guys have any suggestions, write it out on the chat. All right, let's go ahead and do let's do these ones are always interesting. Let's practice. What should we practice, guys? I mean, should we just kind of start get going on a pretty intense integral that I think can stump some people? I'm going to have the integral of 5x. This 5 looks like an s, so I'm just going to make sure that it looks a little better. Over 3x squared minus 4x plus 11. And then we have the dx. All right. So if you're seeing this integral, I'm hoping that it's working. Again, I think my stuff is lagging, so I'm just making sure that it shows up on the screen. But if you see this, go ahead and let me know in the chat, what method should we use? This is a very interesting one that typically is taught in Calc 2, Calc 1. Calc 1 students can learn this, but it's hardly even brought up at all. I just think this is just when teachers want to be cruel with you guys. But again, if you've seen this in the chat, let me know what method we can specifically use for this. Someone's already talking about partial fractions. Let's go ahead and try that. Okay, Lava Mob and Darkness 67 said that we're gonna go ahead and solve this using partial fractions. I kind of agree. Let's see if this works. But before we could even do partial fractions, we're gonna see if we could even factor out that 3x squared minus 4x plus 11. So let's just check and see if we can actually do that. So we have the 3x squared minus 4x plus 11. I just brought that off to the side just to see if we can factor it out. There's many ways that people can factor this. I personally like to use the technically the diamond method, even though there's no diamond there, but it's going to be the x method. And so I'm going to multiply the 3 times 11. That's 33, and that's -4. And we got to find two values. Lucas, this is why we're doing this. Honestly, it could be difficult, but sometimes it's just fun to watch people do some integration problems. So let's see, can we even factor this? Can we find values that factor out to 3x squared minus 4x plus 11? I cannot think of numbers that multiply to 33 and add to -4. The only numbers that I think of is 3 and 11, but those don't add up to anything. So it looks like we can't use that, can we? This is a very unique problem where we try partial fractions initially, and then we realize, yeah, this doesn't work. So we have to try something else. And here's the way we're going to solve this, okay? We are going to start anticipating using u substitution, and we're going to make sure that we rewrite our problem that we have. Let me show you what I mean by that. Okay, so the first thing that I'm going to do is I know that I'm going to have to use that as my u substitution. So if I make this my u, let me actually use a different color. Let's use, we were already using blue. So we're going to use that blue there. Let me just erase all the work here. So like we said, we're going to make u equal to 3x squared minus 4x plus 11. And our du is going to be 6x minus 4. Now, that's only going to help us if we had a 6x minus 4 in the numerator for our integral. And it doesn't look like that's the case. So we have to kind of have to anticipate that and rewrite our problem. And here's the way we're going to do it. The very first thing that we're going to do is we are going to let's do, because we want a 6x, as I mentioned, I'm a little rusty, so I'm trying to figure this out myself. Let's go ahead and don't like this one at all. Because we want a 6x on here. How about, oh my goodness. Okay, so it's like we're gonna multiply a 5, but we're really, actually, I got this. I got it. Give me 1 second. Give me 1 second, guys. Here's what we're gonna do. Let me just erase that green stuff there. So the very first thing that I want to do, because I'm anticipating having a 6x minus 4, I'm going to go ahead and factor out a 5 from the top. And it's going to look a little weird, but bear with me. And we're going to have 5 on the outside, and we have 6 plus 31 over 5 all over 3x squared minus 4x plus 11. Okay, bear with me again. Now what we want to do is I'm going to multiply the top by a 6, but because I multiplied the numerator by a 6, I'm going to have to divide by a 6 on the outside. And now we have 5/6, and then we have 6x plus 106 over 5. That number, let's not worry too much about it, but we're getting close, because if you notice, the whole point was because our u was 3x squared minus 4x plus 11. Our du is 6x minus 4. We kind of have that 6x there. So now what we're going to do, we want that minus 4. So I'm going to introduce a minus 4 in the numerator. But of course, I need to add a 4. So what I'm going to do is I'm going to take the 6x and the minus 4 and put that within one, I guess combine it or put it close to each other. So now I have 5/6 on the outside, 6x minus 4, which is what we want. That's that magic number that we want, plus 186 over 5 plus 4 all over 3x squared minus 4x plus 11 dx. And now, it might look a little more complicated, and it kind of is, but don't worry. Because now what we're going to do is we're going to rewrite this. We're going to break this down into two different integrals. The first one involved the 6x minus 4. And now the other one is going to involve the 186 over 5 plus 4 all over 3x squared minus 4x plus 11. And the reason why we wanted that is because look at that first integral. That one is just going to be solved using u substitution. There's not going to have, or we're not going to have any issues with that. So let's go ahead and do that now. Our u was 3x squared minus 4x plus 11, and our du was 6x minus 4. And now what we can do is we can rewrite this as 5/6 integral of 1 over u du. If I went too fast on that one, let me know in the chat. But again, this is all just, again, we're not studying for anything. We're just having some fun with these integrals. So this is just 5/6 integral of 1 over u du. And then for the other integral, before I even do anything, let's just go ahead and combine these things. We have 1/6 over 5 plus 4 over 5. We're going to get common denominators on that. And that's going to be 206 over 5 over 3x squared minus 4x plus 11 dx. We're going to go ahead and fix that in a second. But if you've seen part of my lives before or any of my videos, you already know that when we're doing integrals, we got to create some space here on the blackboard. So we're always going to shrink our work. And you know we're about to have a good time when the work gets smaller and smaller and smaller. Okay, just to make this more visible, I'm going to rewrite this. This was 5/6 integral of 1 over u du plus 5/6 integral of 206 over 5 over 3x squared minus 4x plus 11 dx. Aha, pretty cool, huh? All right, for that first integral that we had, this is just going to become 5/6 natural log of absolute value of u. I'm not going to worry about the plusing until the very end because we still have a second integral that we need to take care of. Plus, let's go ahead and kind of, fix these fractions here. So we have the 206. So I'm going to bring that 5 that was in the denominator on the outside, and that's going to cancel out with the 5 that's on the outside of the integral. So we have 206 over 6 integral of 1 over 3x squared minus 4x plus 11. And before we even start working on that second integral, let's go ahead and just fix that integral that I circled in green, the 5/6 ln of u. So that's going to be 5, 6 ln. And remember, our u was at 3x squared minus 4x plus 11. And now we have 206 over 6. 206 over 6. Does that even simplify? Just be... I have 206 over 6. Yes, I'm using a calculator, okay? Sometimes I don't want to think about my fractions. Oh, I noticed that I'm not going to have space for that. Okay, let me just rewrite this. 5, 6 natural log of 3x squared minus 4x plus 11. My work was going to be covered by my face. And I'm sorry about that. I think that's going to be better. So minus 4x plus 11 dx. And these pesky, I don't know how to say this. That last integral is going to be such a pain because what we have to do is we have to complete the square. Okay? No partial fractions is going to save us here, unfortunately. So let's go ahead and start completing the square, which I hate. Completing the square is so annoying. I hate writing it. I hate doing it, but it's essential. I mean, honestly, I can't do anything about it. So we have to learn it. So if you hate it just like me, I'm with you, but you have to learn it. Unfortunately, you just have to live with it. Doesn't mean you have to like it, but we know it's helpful. So the first thing that I'm going to do is factor out the 3 from the 2 terms. So we have an x squared minus 4/3 x inside that parentheses. And let me just rewrite all the work that we needed to do. Plus 11 plus 103 over 3. Okay. Oh, no, I was going to bring out the 3. Not yet. Won't do that yet. But here's what we're going to do. We're going to have 1 over 3 and then inside there. Don't forget, because we're going to complete the square, we have to introduce a new value. So we have to divide the 4/3 by 2 and then square it, which becomes 4/6 squared, which is 16 over 36, which can simplify. I think we can divide that both by 4. So it becomes 4 over 9. So we're going to introduce a 4 over 9. And guys, this is not meant to be like a review for homework or anything. This is literally just to have fun. If you're in the chat and if you feel like you wanted to cover something specific, let me know in the comments. On Thursdays, I typically do math survival skills, so we can do something very specific to cover. Today, we're just trying to have fun. And honestly, we're trying to polish off these math skills that I totally forgot about. Okay, back to our problem. We introduced the 4/9, but don't forget, because we introduced the 4/9, we have to make sure we subtract not a 4/9, but we have to distribute the 3 to the 4/9. So that's going to be 4/3. Okay. Guess what? Don't have space. We're going to make this smaller. I mean, do we expect anything else? Right? Sometimes these are fun. Not sometimes. They're always fun. But the problem with it... Oh, shoot. Sorry, I got distracted with the chat here. But the problem with this is that it definitely throws some people off. They're like, yeah, I'm not dealing with this. I don't want to deal with any fractions. Don't give me any of these problems. But that's okay. Sometimes you can just kind of step away for a little bit. I'll bring it back and I'll do a different integral that we can all sort of keep up with. All right, so we have 5/6 natural log of 3x squared minus 4x plus 11. Back to our integral here, 103. And an integral of 1 over 3 times x minus, now we know this is going to be 4/6. Can I simplify that? I'm just going to do 2/3. So minus 2/3 squared plus, and then don't forget that initially we had 11 minus 4/3. So that's going to be 33 minus 4. That's going to be 29 over 3. Hey, not bad. Not that bad. All right. As you can see, this, hopefully, I don't know if you can see it, but this is an arctan integral. But before we even go ahead and integrate this using arctan, I'm going to go ahead and factor out a 3 from both terms so that I have this integral here. 3x squared minus 4x plus 11. So I factor out a 3, so this becomes, on the outside of that integral, 103 over 9. Integral of 1 over x minus 2/3 squared plus 29 over 9. Okay, and that bottom integral we're going to make our u equal to x minus 2/3, so that du is just equal to dx. Perfect. We're going to use arctan for that. Just give it a second. And then our a squared is 29 over 9. So our a is root 29 over 3. Let's rewrite this whole thing. So we have 5, 6 natural log of 3x squared minus 4x plus 11 plus 103 over 9 integral of 1 over u squared plus a squared du. Ooh, that is an arctan. That is an arctan. Let's finish it off. 5, 6 natural log of 3x squared minus 4x plus 11 plus 103 over 9 times, and remember, arctan starts off with 1 over a, arctan of u over a. And I finished integrating that, so I'm going to put a plus c. But now we have one last step. We just have to rewrite everything in terms of x. So I have to substitute our a value back in and in our u value. So this becomes, let me make it a little, I hope I have enough space. Actually, for the grand finale, let's just make this smaller one last time just so we can rewrite everything. And sometimes you just have an integral like this and it just gets you pumped. Second integral that I've done in about a month. Feeling pretty good about it, I would say. Okay, so this is just gonna become 5, 6 natural log of 3x squared minus 4x plus 11 plus 103 over a, or 103 over 9 times 1 over a, which is root 29 over 3 arctan of x minus 2/3 over root 29 over 3 plus c. And we can simplify that, but that's our integral. Pretty sick. Pretty sick, huh? Okay. I think that was a good one to start off. Let's do one that just involves partial fractions. I'm hoping that we can make it somewhat easy. Let me look for an integral that involves partial fractions. So if you're still in the chat and if you want to review a problem involving partial fractions integration, let's find one. Again, I don't want to make it too hard. Let's go ahead and try. Let me look for one. Give me 1 second. Okay, I found a good amount. Let's go. Okay. Integral of x plus 14 over x squared plus 7x plus 10 dx. And the biggest hint that we can get out of this is that we know we have to integrate using partial fractions. So if you're in the chat and if you see this problem, let me know what the first step should be. And again, it's partial fractions. This isn't a hidden problem. This is literally just partial fractions. So if you see something that we feel that we can do in order to start this off, let me know. Okay. Let's try rewriting the bottom. As always, every time we're doing partial fractions, this is going to be x plus 14 over x plus 2 times x plus 5. Nice. When we have it factored out, that just means that we can go ahead and use partial fractions here, which is pretty convenient. So I'm going to write this in a different color so that we can kind of just remember that this is like almost a separate problem before we start integrating. We have x plus 14 over x plus 2 times x plus 5. That's equal to a over x plus 2 plus b over x plus 5. And if we combine these, don't forget we have to get like terms. So the numerator just becomes a times x plus 5 plus b times x plus 2. And keep in mind, this is just an Integration Bee Tuesday. We're not here to kind of go over every single method in detail. This is just, you know, kind of a surface level refresher on certain methods. So if you feel like I wrote something that was a little bit confusing, let me know so that I know that that's something that we should cover in detail on Thursday. Okay, so as I mentioned, this has to equal to the numerator. I'm just going to put x plus 14 is equal to this a times x plus 5 plus bx plus 2. Some people do this differently. Some people like to plug in something inside this parentheses so that it cancels out, meaning that they're going to make x is equal to -5. So what that means is we're going to plug in -5 for every value of x in this problem. So we'll do -5 plus 14 equals a times -5 plus 5. I'm just going to show all the work for this one. B times -5 plus 2. And look what happens. That -5 plus 14, that's just going to be 9, equals that first parentheses, -5 times, or -5 plus 5 is just 0. So that entire value goes away. And that's going to help us isolate the b variable, and we're going to be able to find that value. So we have b times -5 plus 2 is -3. And if we divide the -3 to the other side, we get -3 is equal to b. Perfect. Okay, what more do you want? And so now what we're going to do is we're going to start here where I circled in red. And we're going to do the same thing, but now we're going to cancel out the b variable. We already know it's -3, but let's cancel this out. Let me show you what I mean. Let's go ahead and plug in something to that parentheses, the x plus 2, to cancel it out, meaning that we're going to make x is equal to -2. So we have -2 plus 14 is equal to a times -2 plus 5. Whoops, I have the wrong color. Plus b times, and as I mentioned, I'm not going to put the red there. We already know it's going to cancel out, so we're over it. We're done. And now let's go ahead and find the value of a. On the left side, -2 plus 14 is just +12 equals a times +3. And if we divide the 3 to the other side, we get 4 is equal to a. That's it. Partial fractions. This is one of the most basic partial fractions problems that you can have, and it's just a method that you should definitely know. When do we use it? It's when obviously the denominator is greater than the numerator, but also if you look at the denominator, hey, we can factor that out. And if you can factor it out to make it somehow simpler for yourself, or visually that you can see like, oh, okay, I can factor this out into multiple terms or binomials, then we use partial fractions. Yeah, you always know it's a good problem when we have to shrink this and make this a little smaller. So let's go ahead and do that now. Hope I caught that. Let's see. Here we go. All right, we found the value of a and b. So we are gonna rewrite this. So remember, this x plus 14 over x plus 2 times x plus 5 dx was equal to the integral of a over x plus 2 plus b over x plus 5 dx. We already found the a value and the b value, so we can go ahead and plug those things in. So we have integral of a, which is 4 over x plus 2. I'm going to put the dx there, plus, and then let's just separate this into two different integrals, -3 over x plus 5 dx. All right, in the chat, how do we finish this off?